Year 5 and welcome to your maths lesson. Now, today we're going to be looking at comparing and ordering fractions greater than 1. So we're going to be using the skills we've learnt in the last 2 days to help us with our lesson today. So like I said before, take it at your own pace, okay? And remember to visualise every fraction as like a pizza, okay? And it will help you. But before I decide to confuse you any more than I probably already have in the last 2 days, let's warm your brains up looking at some of our multiplications. So set yourself a timer, 5 minutes, pause the video and have a go. Okay, 635 divided by 5. Well, we know there's going to be no remainders because it ends in 5. Okay, answer is going to be 127. What is the area of the square? Well, we know that the area is the length times the width. We know that both edges here are going to be 25. So 25 times 25 is then going to give us 625. Okay. Work out 43,000 divided by 100. Okay, well, we know in dividing by 100, it's got to get 100 times smaller, so our digits have to move twice. Okay, so our answer is going to be 430. Round 2,427 to the nearest 10. This is going back to what we learned back in September, okay? So wherever you are, Brandon, I know you're going to get this right because you're our place value king. So if we're rounding it to the nearest 10, okay, it's the tens number that we're looking to potentially change, okay? 5 or more, raise the score. 4 or less, let it rest. Well, it's higher because we're looking at our ones, which means that rounds up to a 3. So my answer would be 2,430, okay? Now, if you had to go at the time one here, we can see we're just coming up to 6 o'clock, so it's 5:50. And if you're writing that in 24-hour clock, that's going to be 17:50. Okay? Now, let's warm your brains up a little bit more with our fractions. Okay? So, think about what you know about common denominators and common numerators, and have a think about what multiples and factors might be able to match so that you can change them so that their numerators or denominators are the same. So you might see a match here with the denominators, you might see a match here with the numerators and the denominators. It's entirely up to you. This one's a whole, so that one should be easy. Okay, pure easy, that could be any number. And this one here, well, we can see that there could be a match between the numerator or the denominator. So sit yourself 5 minutes, pause the video and have a go. Okay, so number 1, okay, is going to be 6/27, okay? If we think about it, how do we get from 9 to 27? Multiply it by 3. So you do the same to the numerator. 2 times 3 is 6, okay? Now this one here, we can see that we could either have changed the numerator or the denominator, okay? But if we change it so that our numerators were the same, we could change it to 14, which would make it exactly the same. Now here, this one, because it's a whole, okay? We know said here that it's got to be greater, okay? That tells me that number's bigger. Now, we know that a whole would have been 7/7, so it's got to be an improper fraction. It's got to be more than one whole, so it could be 8 or anything beyond that up until we get to 13/7. Now, this one here, we can look at this one. We can change this one, okay, so that our numerators are the same. We can't do our denominators because 8 doesn't go into 19. But we can work out, we get from 2 to 1. We just times it by 2. 1 times 2, do the same to the bottom. That tells us that 2/16 is actually bigger because the numerators here, although they're the same, this piece has been split 16 ways, whereas this one's had to be split 19 ways, which means that the pieces are actually smaller. So well done if you got those correct. So let's blow your brains a little bit more today, shall we? So we need to work out what the common equality is. Now, I want you to have a think. What do you notice about both of those fractions? Good, the denominators are the same, okay? So we know if the denominator is the same, the greater the numerator, the bigger the fraction is going to be. So is 11/7 bigger or is 9/7 bigger? Okay, well, we know it's then going to be 9/7. Okay, if we show you this, okay, so here you've got 11/7, 2, 4, 6, 7, 8, 9, 10, 11. And here we've got 9. Okay, and here we can see that the 11/7 that's left over here is actually bigger. Okay, because we've got more portions of our sevenths than we do if we look at it, if we only had 9 pieces. So here we've got 11 pieces of 7, and here we've only got 9 pieces out of our 7. Okay, let's have a go at this one. See if you can do this one. What do you think you might need to do? Okay, so I might have to change the denominator. So you have to think, well, how do I get from 5 to 10? Okay, and then what do we then need to do to the numerator? So let's have a look at them. So here we've got our 7/5, and here we've got 13 lots of 10. Okay, I can clearly see here, okay, that my 7/5 is bigger. okay? Because these portions here are bigger than my tenths are. Now, if you did it a different way, you might have looked at it where we thought, well, tell you what, let's convert the fraction. So to get from 5 to 10, we'd have multiplied it by 2. So you do the same to the numerator. That would have given us 14 over 10. And there we can see that 14 over 10 is bigger than 13 over 10. Okay? So if you use the multiplication facts on there, not a problem. So now's your opportunity to see if you can do that on your own. So this is just going off the skills that we looked at yesterday. So I want you to pause the video and have a think. How are you going to compare these fractions? Are you going to try and make the numerators the same, or are you going to try and make the denominators the same? This one here is a trick question. Okay, so pause the video and have a go. Okay, well, I can clearly see the common factors here of 24 and 12 is that 12 goes into 24. 24 is in the 12 times table. So I can multiply this by 2, which means I multiply my numerator by 2, which gives me 32. Now I can see here that 32 out of 24 is bigger than 29. I've got 32 additional pieces of my 24. Here I've only got 29, so that makes 16/12 the biggest number. Here I can see, well, I can't fit 26 and 10 because 26 isn't a multiple of 10, but 21 appears in the 7 times tables 3 times. So if I multiply my denominator by 3, I multiply my numerator by 3, and that gives me 30. And I can clearly see that 30 is bigger than 26, making 10/7 bigger. Now this bottom one is a trick one, okay? I'm not going to convert any of my numbers, okay, because I'm going to be looking at this fraction. Okay, here. Now I could convert this, and I could do it so I multiply my 4s. So I'm going to multiply it by 11, which gives me 66. But I'm actually looking at this thinking that there's an easier way to have worked this one out. What's double 44? 88. So here I'd have 2 whole fractions, 2 whole portions, plus an extra one. What's double 4? 8. Now my numerator is smaller than 8. So I've got less than 2 wholes here, where I've actually got more than 2 wholes there, because 2 lots of 44 is 88. So I'd have 2 wholes and 1/44th, whereas here I'd have 1 whole and I'd only have 2 left over. So automatically, without having to convert, if I knew that was already going to be double the numerator, and this one was less than double the denominator, then I automatically know that that one was the biggest number. Equally though, if you did the conversion, that's fine, not a problem. Okay, so let's consider this one here. So we've got 15/13, okay, and here we've got 15/10. Now I can clearly see that 15/10 is bigger, okay, but equally, that's because I'm looking at my numerators. My numerators were exactly the same, and the rule is if the numerators are the same, the greater or the bigger the denominator, the smaller the fraction. So we're going back to our pizza here, okay. I've got my pizza here, and my pizza's been cut into 13 slices. Whereas Miss Ashford's pizza that's over here, hers has only been split into 10, which means whoever has a piece from Miss Ashford's pizza is going to get a bigger slice because it's had to be cut into less pieces. Therefore, everyone gets more. Remember that analogy of a pizza. If you've got half a pizza, you get a big piece each. But then you go into thirds. Then you go into quarters, then you go into fifths. Although you have more slices of your pizza, they're actually getting smaller and smaller and smaller. So actually, Miss Ashford will have a bigger slice from her pizza than anyone's going to get from my pizza, okay? So let's see if we can apply the same logic here. Okay, now we know when the numerator is the same, just like we've just said, the bigger the denominator, the smaller piece that you're going to get. But I don't see my numerators here as being the same, or my denominators as being the same. But what I do notice is that 9, okay, on 27 are in the same times tables. Now to get from 9 to 27, I multiply by 3. So I have to multiply both my numerator and my denominator by 3. So that now gives me 27 out of 15. So here, looking at my rule, my numerators are indeed the same. They're both 27. But my denominator here for Miss Ashford's pizza is 15 slices per pizza, whereas my pizza over here is 24 slices per pizza. So that actually makes Miss Ashford's pizza slices bigger than mine because hers have had to be cut up into less pieces. Mine got cut into more pieces, meaning anyone eating from my pizza is going to get a smaller slice. Okay? Now, I want you to consider the same thing for this one here. Now, we don't have the same numerators or the same denominators, but I want you to have a think. Can we convert one of those fractions so that either the numerator or the denominator is the same? And then based on our rule of it either being cut into 5 pieces or 7 pieces, Which one is going to be bigger and smaller? Pause the video and have a go. Okay, well, I can see that 4 and 8 are in the same times table, so I can think, well, how do I get from 4 to 8? I'm going to multiply by 2. So if I multiply both my denominator and numerator, I've got 8 out of 10. So here I've got the same numerators, but my denominators are different. Now, Miss Ashford this time round has got her pizza cut into 10 slices, whereas I have my pizza cut into 7 slices. So who's actually got the biggest pizza, me or Miss Ashford? Woohoo, it's me. Sorry, Miss Ashford. I'm going to be the pig today. I'm going to have the bigger pizza. So because mine's only cut into 7 pieces, that means everyone gets a slightly bigger piece. Whereas Miss Ashford's pizza, which has been cut into 10, yes, 10 people can have a piece of her pizza, but they're going to get a smaller part. Okay, so well done if you got that one correct. Okay. Let's consider this problem-solving question here. So Rosie and Amy have both baked some cakes and they got a little hungry and they ate part of their cake. That sounds like someone I know sitting over here. So who has the most cake left? So let's have a look at this first. What do you notice that's the same about the mixed numbers? Yeah, they both got 2 wholes. So let's just get rid of them, okay? We don't need to acknowledge those because we know that those are both equal. So now all we're left with to focus on is the fractions. So now we need to think, well, how do I now still work out who has the most cake left? Now, we go back to the rule of the numerators are the same. We don't have the same numerators, but I can see that 3 and 6 both go into the same times tables. So I can multiply my 3/4 fractions here by 2. That's going to give me 6/8. Now here I can see both my numerators are the same. However, Amir on this side has got his cake cut into 7 pieces, and Rosie on this side has got hers cut into 8 pieces. So that actually means that Amir has got the most left because his pizza, his cake, is cut into smaller slices. So let's now consider the question of who's got the most cake left, okay? So although that's how much they've eaten from their cake, you need to work out, well, how much of their cake is left? So what do you notice about each of these fractions? Oh, I'll give you a clue. They're 1 less than a whole cake, aren't they? Okay, so they've both got 1 slice left. Okay, so Rosie has got 1/4 left, whereas Amy has got 1/7 left of his cake. Now, we already know that the smaller that denominator is going to be, the bigger that piece of cake is going to be. This cake has only been cut into 4 slices, and she's got a whole quarter of it left, whereas Amy's cake was cut into 7 slices. So someone's going to get a much smaller piece. So this time round, if we look at it from the fractions on this side, we can actually see that Amir had the most left over, okay, because he has got the bigger portion of his cake, okay? So now that I've confused you, probably more than you already were at the beginning, I want you to now have a go at doing questions 1 to 4 on your worksheet. If you are stuck or confused, go back and watch the modelled examples in the PowerPoint, okay, to help you and see how you get on, okay? Good luck, year 5.